Good afternoon, everybody. If you could just come in and take your seats, thank you. So this afternoon we've got a talk here from Douglas Bagnall, and Douglas is going to be talking to us about Gstreamer and multimedia programming with Python. Douglas is a Wellington local, and I'm very much looking forward to his talk. And please give him a round of appreciation now.
Right. Can you hear me?
No. Yeah, you're fine.
It's just Grant. I'm talking about Gstreamer and how you can use it with Python. Gstreamer is a multimedia framework, and a framework means it's a library that tries to take over everything in its domain. It runs on, it's used by all the Linux desktops and on all those phone operating systems you've heard of but never seen, apart from Windows probably. And it's based on a concept of pipelines, which... Okay. Can I speak up? So pipelines are made of elements that are linked together, and this is now I used Inkscape to make my slides. That's why it's all this slipping back and forth stuff. I'm sorry about that because it's kind of like about 5 years out of date for having slides that do that. But I used Inkscape because I started drawing with these diagrams and I realized I could do my entire slideshow in Inkscape. Anyway, elements in this presentation are drawn like that. They've got these pads which are either sync pads or source pads, and when you're using Gstreamer, you take a whole lot of elements and link them together. And there are various kinds of elements that can, some just emit something. They take, maybe they take a file from the file system and put out whatever's in it, or they might stream from the net or capture from a camera, and then some of them are a sync, so they don't emit anything, they just take in a stream and put it into a file or onto the screen or onto the net. And then some of them filter things, they change it along the way, like that one in the top right, top left. And the top right is one that isn't changing the content, it's just analysing it and sending out messages. Then other ones combine streams or fork them. Now, a simple Gstreamer pipeline would go like this. This is a command line syntax for making a Gstreamer pipeline, which isn't Python, but it kind of gives you the idea. So it's based on the same concept as Unix pipes, sort of, except they can't use the Unix pipe symbols because those are already taken by Unix. So they have to make do with what's left, which is just the letters and exclamation marks and maybe a few other things. So the exclamation marks, they mean a pipe. So this is setting up 5 elements and passing something between each one. And so you name your elements, you put them in the order that you want them to go, and they find the links automatically. And what this is doing is playing a video. The first element in the row reads the file, and then it demaxes the OGG file and decodes it, and then the video convert, what that's doing is just changing the color space if it needs to, so that the sync, which would be putting it on the screen, can cope. And if it doesn't need to, the video convert will do nothing. This is fragile and kind of well, like the X image sync only works on X11, and even they're not very well. So there's a concept called a bin in Gstreamer, which is like a wrapper around a set of elements. And the auto video sync wraps a whole set of elements, and it finds a way of putting video on your screen that suits your computer. So this is the same thing as that, except it probably uses a different image sync, and if you used a Mac, it would use whatever would work on a Mac, and so on. And you can actually use a decoding bin to do the whole decoding part of it. So this is kind of simplifies what you need to do, and you can actually, now all of this is just would play a silent video. I mean, I could do a demo, but it would just look like a video. So what you need is two decoding. Right, okay. Inside the decode bin, it decodes into two streams. One of them is video and one of them is audio. And the video syncs and audio syncs, they have capabilities on their pads which kind of say what they'll take. And then the decode bin has capabilities on its pads, and they negotiate. And so you say, I want to connect these two things together, and they'll find the right way, a way that'll work. And now you can try and specify how they should link by picking out the pads and saying, I want this one to go to that one. But usually you don't have to. And then there's even a bin called the play bin that you just tell it what you want it to play, and it'll play it. And so with this, we've got as far as this command. But Gstreamer can do more complex pipelines than this kind of thing, which is why it's any use. But in fact, there are probably 100 media players out there in the world that are based on Gstreamer and do what mPlayer does, including Totem. And I think every desktop environment has at least 2 Gstreamer-based media players. Anyway, so one slightly more complicated thing you can do is combine streams together. So you take audio maybe from the microphone, maybe they're doing it now, and video, and encode them both, and then mux them, which is muxing involves taking snippets, kind of interleaving 2 different streams. So it's just a way of banging them together in one file. So AVI is a muxing format, and so is Matroska and stuff like that, pretty much. And you can mux them somewhere, send them over a stream, and undo them on the other end with Gstreamer. Of course, you can do that now, like VLC does that pretty well. So here's an example, a real-world example, where Gstreamer actually does something that is hard to do with little pre-built tools. So this is a really common case in an art gallery where you have the artist wants synchronized video, and in the case I did this for, they wanted 4 screens that were synchronized with the sound. And the traditional way for art galleries to do this is to push all the buttons on the DVD players at the same time. but it goes out of sync. And so that's why in art galleries, there's all those attendants, you don't know what they're doing. They have to be there when they have to push the buttons. So with Gstreamer, one way to do this is you start off with a video. You make a video file that is big enough to hold your 4 pictures, and then you split that video stream. You read it. You split it into. I've missed out a step. Yeah, I missed out the decoding. So pretend it doesn't say file source. It says decode bin or something. Split it into 4 streams of video, and then I'll talk about the cues soon. And then crop each of those 4 streams, crop it to the bit that you need. So you're actually playing the same video on all the 4 screens, except with the other 3/4 of it cut out. And then the audio is going all the way around simply down to the end. And now what the cue does is it's slightly misnamed. It decouples threads. So it's sort of now if they were all trying to play at the same time, all in one thread, they start banging into each other, and it freezes up. And this is like one of the most common problems with Gstreamer is people try and do something and it freezes and there's no message saying why. It's because they didn't put a cue in the right place. And so if you're using more than one output, you just put cues everywhere and it works. So it's kind of the video comes into the queue and then it gets copied across, or it also gets handed over with a locking kind of thing. Now this was done in 2002 in Pakistan with CRT monitors. They wanted to watch TV on a big scale. And it was that's it in action. So that was when Gstreamer was quite young, and they used 16. In the old days, there was a thing called Zinorama that you could actually have more screens than you can now. Like people have fixed X, so you can't have so many screens. But they'll fix it again. Now this is another kind of simpler case. This is a artwork that I did myself, where there's a camera looking at the screen, and then there's 2 projectors projecting onto the same screen, and the video that's going through is transformed with a Sparrow transform. Which, there's 2 steps to this. The first thing it does when it turns on each day is it looks at the screen and works out what angle it's looking at the screen from. So whereabouts, if it projects things and sees where they end up, and it kind of maps out the space it's working on. And then it obliterates everything that's there. This just looked better black, this one. So say it was looking at this Amsterdam scene, it would invert it and then project the inverted image onto what it's looking at in such a way that it cancels out what it sees, and which would just make it grey or white, except it also puts on images or video of sparrows flying about. And there's 2 of these, and so they're both trying to wipe out each of the sparrows, and you get swirly feedback, really. And right, so the thing about this artwork, it's a simple pipeline, but it's quite complicated inside that that element that I had to write to make it work. And I wrote that in C because it's the normal way to write Gstreamer stuff. It's not all that nice, but there's things to help you. And you can write them in Python. There's other things to help you with that, but I don't know how, I don't use them. I think it's probably only really feasible with audio, not with video, but that's, I haven't proven that. So put that aside. Here's another one, another kind of pipeline you can do. Now, one of the things I do is classify audio with a recurrent neural network. And to train it up, you need to play it lots and lots and lots and lots of audio. And it works best if you play it several hundred files at the same time, because if you're training an ordinary neural network, you give it bunches of examples at the same time, like 100 at a time, and in a random order. But with a recurrent neural network, you're not dealing with the things in a random order, they're in the order they're in. So that's the whole point. So to get a kind of, if you trained it on one file, it would get trained all the way over this way. Then it would get trained all the way over that way, like a minute later when the class had changed, and it would just learn to be confused. You want to train it on a whole lot of channels, so some of them are going that way and some of them are going that way, and it kind of finds a middle path. I didn't explain that very well, but I should have prepared. There's Python, the green one. So there's like 100, 200, or an arbitrary number of audio files that are going through into an interleave plugin, element, which just takes mono channels and outputs however many, like say 100 channel audio into the classifier plugin. And what Python does is it knows what the right answer for these files is at the various times along each file, and it tells the file sources to what file to play, and it tells the classifier what to expect. And then, so the classifier learns, and then the audio output from that, it's actually no use. So it goes into a thing called a fake sync, which is just like, it's like Bagnall, just goes nowhere. So you can actually turn any element into a sync just by putting a fake sync on the other side of it. There's also fake source. I don't know what good that is. And then when it's classifying, when you're asking it for an answer, you just give it one at a time, and it'll tell you the answers. So it's the same plugin, but in a slightly different mode. I could do a demo. How much time do I have? 5 to go? I won't then, because I should get on to Python. So back to this one. How you'd normally be told to do this in Python is you do this big long kind of, not really long, but boilerplate kind of stuff. You import GI, which is like the G is the G that everything in GNOME stands for, whatever that G is. Everything you deal with when you do programming with Gstreamer starts with G. Like if you do programming in C, it's just G, 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 G. Even like things like int is gint. And anyway, And that's kind of like a magical bindings that are generated somehow from the from Gstreamer. I think for G-object introspection or something it stands for.
G-object.
Yep. So you get bindings for free with GST, with Gstreamer 1.0, and then people always in the examples they have a class, so it doesn't need to be a class, and they go through all this blah 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 repetitive stuff, and then you do this thing at the end. But you don't need to do it like that. You can actually just use the same syntax that you use on the command line and just say, do this, and it works just the same. It's the same pipeline you get this way as the other way. So if you know that syntax, it's much similar to do it this way. But and another way to do it is to kind of make a helper function that does all the various steps that were up there somewhere. All of this stuff, you can just make it do them all in one go. Right, and you can, did I have that in there? Yeah, that bottom bit here, if you do that, you can tell it to dump out a dot file that describes what the pipeline you've made, so you don't need to draw your own in Inkscape. And now this is how you would make this kind of pipeline where you're getting a whole lot of things interleaved into one. You just loop over it, link them together. I'm not actually talking much about Python because you can just look all this stuff up. I mean, it's like the concepts of linking things together is what matters. And now in this one, I've put caps on in that pipeline that just kind of tell it what kind of audio will accept. And now this is an example that kind of shows why everyone uses an object, because before you didn't really need an object, but I mean a class. Here it's adding a message kind of handler, so when you get messages from Gstreamer, it will print them out or print out something about them, and you get all this rubbish. And you can ask it with to have more specific messages, like if you put the message element handler on, you can get it so it's just the things that you're trying to say, you're trying to get your plugin to say will come out. Right. There, that'll do. That's me.
Very much, Douglas. Okay, do we have any questions for Douglas, please? Please put your hands up. All right, at the front here, 1 second.
Do you know if anyone's played with hooking some of this up to the scientific Python stack for signal analysis and that kind of thing, or?
No.
Any other questions, please?
Yeah, hi. I was just wondering how you'd go about connecting 16 screens to a PC or even 4.
Right. Well, actually, what they did before, you have 2 cards, and when that was 2 or 3 years ago. In those days, you'd have a VGA and a DVI, and on the back, even the cheapest cards, which was what I used. And then you could make them do. I think I had to tell it that was actually one widescreen, because Zinarama's gone and whatever was the new thing couldn't quite cope with 4. And so you get 4 that way. And what they actually did is they had 5 PCs, and they had one of them streaming to the other 4. So there was 2 lots of each of the 4 client PCs would get a quarter of the image, and they'd cut that into 4. And they just had 4 PCI cards, I suppose, because 2002 in Pakistan, that's what you'd have.
Any other questions? Okay, I just have one question. Douglas, how did the art gallery respond when you told them you had a fantastic programmatic way of pushing all the start buttons at once for them?
They paid me money.
Very good. Thank you, Douglas.